So, find QS means find the length of QS, which in this case is the flagpole. And what we want to do is turn it into a right angled triangle problem. And I think it helps if you redraw the right triangle from the diagram. QS is what you're trying to figure out. So if you want to label that X, you can. RS is 10.3. What else do I know about that triangle right there? Oh, that is 56 degrees. Drawing's a little bit too small, sorry about that. So from this point you determine Pythagoras or trigonometry. It has to be trigonometry because an angle is included and I'm only given one side. So we do the SOHCAHTOA thing, and from this angle, that's opposite, that's adjacent, it's going to be tangent 56 degrees equals opposite over adjacent. And what I said, I labeled QS X. If you want to leave it as QS, that's fine. Doesn't really matter. And we're going to multiply this to solve. Tangent 56 times 10.3. And it just cleared. Why did it do that? Okay, so that one was trigonometry. I put RT and SU because they're going to be the same. Diagonals of a rectangle are equal. Okay, so if I want to draw that on there, great, go ahead. You don't have to, but you can see the right triangle right there, which is lying flat on its side. So in the working, I'm looking at that triangle down there. That's S, that's T, that's R, that's 10.3, that's 5.6. Mr. Pythagoras right there. And just to be different, instead of labeling that X, I'll just leave it as RT. If you want to put an X there, you can, that's fine. But the main thing is you use Pythagoras because no angles are there. So Pythagoras, remembering the hypotenuse is by itself, and I put that RT in brackets just so it doesn't look like I'm squaring the T. You wouldn't have this issue if you just used x. So, $137.45. And we all know that the opposite of squaring something is square rooting. Try to keep the working neat, meaning like the equal signs lined up and all that. And on the calculator, that number's in there. So if we just square root answer, that comes up on either calculator, and we get what we want. 11.7 to 1 decimal place. Looks good. Okay. So that's cool. And some students, once they get the answer here, this is a multi-step problem, which means if you got that wrong, sometimes the errors go through to the next problem. So if you were to get this wrong, then your calculating of this angle would be wrong as well. Okay? So, great, 11.7. Let's go to the next one. Find angle QUS. Where is angle QUS? Let's see. Remember that middle letter is always the vertex? So, QUS. Okay. QUS is that angle right there. Where's the right triangle? Where is it? Now it just looks confusing, but right there, even though it doesn't look like it, is a right triangle. Because of the perspective of the 3D drawing, it doesn't look it, but it is, and that's what's going to fool you on the test. So, what I want you guys to practice here always is drawing the right triangle. There's S, there's Q, there's U. That's what I want to figure out. What's US? Besides United States, of course. Yep. How do I find that length? Oh wait, it's the same as that, remember? I told you that the diagonals were the same. So if you found RT, you also found US. It's 11.7. Tricky. What's QS? Wait, I don't know. What's QS? Oh wait, I already figured that out right here. 15.3. So, all of these problems are connected. I'm finding an angle. It's trigonometry. That's Mr. Opposite. That's Mr. Adjacent. It's tangent again. The tangent of that angle, I'm just going to call it angle U for now, because in my drawing that's fine, equals opposite over adjacent Remember, whenever we're figuring out angles with trigonometry, we use inverse tangent, not tangent minus 1, inverse tangent. That's what we want when we do angles. (52.59 degrees), and I say, if you put 52.6 to one decimal place, you'll get it right. Great, good for you. But remember, the protractor, getting 1/10 of a degree is pretty hard to do. So I would just raise that to no decimal places. Just say 53. You could say 0 dp, or a better way to do it would be 2 significant figures, because degrees don't need decimals. None of us here are going to measure anything to the 10th of a degree. That would be just silly. And that is some good practice right there. That's a good job, Mr. Okay.